So yeah, this is Dr. Chris Nash. My name is Luke. A big thing that we teach here at Point Blank are our degree programs. So we have a multitude of different pathways available from a foundation year through to Bachelor of Arts honours degrees in music production, sound engineering, DJ performance, vocal performance, business, songwriting, and the main one I think which might interest most people is the software engineering Bachelor of Science degree. We also do a Cert HE in radio, audio and podcasting. To talk to you a bit more about our Muse course, it's a Bachelor of Science, as mentioned. It's validated by Middlesex University, who we partner with. It's a 3-year traditional degree program, and we're actually offering a £9,000 scholarship to any student that starts the course with us, that we pay to you, and that can go towards awesome equipment and helping you study the course. We've got our course coming up in October, and we're still accepting applications. So if there is anyone here who's interested, do apply. We're still accepting applications, and we'd love to consider you and hopefully see you on the course. Another thing I just quickly wanted to mention about studying the Muse course with us is for every student, we're also going to be giving them a Muse development kit, or MDK, which basically is crammed full of great goodies, as you can see up on the screen there. But basically everything you need to, start programming and coding and, developing software that you can imagine. So that's going to be given to every single student. So a nice little addition. And now I wanted to, pass over to Chris.
Cheers, Luke. Hello. The Muse course is something quite new. Obviously, there's been music computing courses in the past, music informatics, but this one is completely geared towards professional practice. It's about getting people who are ready to work in the industry, and it's quite a novel approach that we take. So that's what I'm going to be talking about. I'm the first speaker. I'm just going to give you a quick overview of the ethos behind the course. And cause there's music technology courses out there, but this is not just about using technologies, it's about making technology. I'm sure this is something that excites everyone in the room. Obviously you've got DSP, you've got synthesizers and effects, and you'll pick up the advanced production skills as well in the first 2 years. But then basically as you move on, you'll actually pick up the best parts of a computer science degree, but entirely devoted towards audio software engineering. So what we try to do is a bit more. We don't just teach you how to make synthesizers and effects, but we'll teach you how basically industry works, how to quality assure things, what agile software development is, so that basically you are not just a graduate, but you're like a graduate with 1 year of professional experience. And we're getting industry involved, not only in the design of this program, but in the creation and the teaching of it. So in the 3rd year, they'll come in, they'll teach the students about current practices, they'll give challenges for hackathons and things like that. And obviously, this is a fantastic opportunity for industry to meet the next rising stars, and for students to obviously get a job. We've been working with a lot of different people in the industry who are basically telling us what they need, because it's very, very hard to find someone who's expert in audio, and someone who's expert in software, and someone who's expert in music, and someone who's expert in psychology for user interface design. So there's a little bit of all of that on the course, and it's specifically designed to produce Renaissance men and women who are expert in all these fields. So lots of different career trajectories. Obviously, audio software development, but artist makers as well. And we'll talk a bit about how we actually try to change the mindset of people on the course as well, to have you thinking differently about what music is and what audio is, so that you become a more versatile creator. So this is the Muse course. It's obviously in a very big font, but don't worry, I'm going to drill down into mainly the first year, actually, because we've got a really innovative program, basically, that takes you from 0 to C++ in a year. And that allows us in the 2nd year to go into advanced DSP and advanced techniques. And whereas other courses, if they even teach things like Juice, will wait until the 3rd year. By the end of that 2nd year, you'll be a capable developer. So that in the 3rd year, you can be working on the cutting edge technology, AI, GPU audio, and you'll be learning about how industry works. So I'll talk about this in a second, actually. So this is completely different speaker. Hi. The first talk. So what I'm going to do in my first talk is basically talk about some of the techniques and some of the tools that we use in the first year to get people, started with programming. I don't know if you know this, but computing is in dire straits at the moment. People are disengaging from courses, and young people are finding it really, really challenging. Digital literacy has dropped, so we need to rethink the way that we actually teach. And which is why we've taken such an innovative approach here. Hopefully you'll agree. So I'm going to be talking about the first year, and I'm going to be talking about the tools that we use in the first year, which include Manhattan, which is a procedural music editor that we use to teach computational thinking. So changing people's mindset so that they actually are ready to learn C++, which comes along in the second module. And talking about some technologies in that module which allow people, it kind of smooths out the cliff edge learning curve that you get with C++ and Visual Studio and Xcode. About me, so I've got lots of different hats. I did a PhD in music software design at Cambridge, but that was mostly about studying the kind of psychology behind learning and creativity. So that's allowed me to design some interesting pieces of music software, which I'll demonstrate, and I used on the course. Enables me to work out how to teach complex things like music and coding in different ways. And has allowed me to do lots of exciting projects with companies like Steinberg, Yamaha, and the BBC, for example. So what Muse is very different, okay? It's computer science remixed. And we're trying to make it more accessible. We're trying to bring in audiences that haven't got into computing before. And we're trying to adapt to kind of people who have never programmed before, okay? But we're also trying to get them far further along in the space of 3 years than you can on most music technology courses so that you are ready to be a professional. So yeah, no coding experience required, but you come out as an industry professional. But it's not a 3-year course, it's actually 3 stages of a 3-year course. So even that first year, you'll be a capable C++ developer by the end of it. And the second year, you'll have actually the skills to create almost anything in software, full applications and things like that. And then that stepping stone to industry in the third year. I'm going to talk about the first year, basically, which comes in 3 phases. We get you ready. We teach you programming through music. Then we thought, well, let's get C++ in at the second module. They're ready for that? Sure. We've got a slight trick there. And then at the end of it, all the rest of C++ and the Visual Studio. A couple of concepts. Who knows what flow is? Ever been in flow, absorbed in an activity? This is my PhD work, basically. So basically, if you're in flow, you're the happiest you'll ever be, and the most creative you'll ever be, and it's a great blueprint for learning. But if the challenge is too high, you get anxious, and if it's too low, you get bored. So the challenge now in delivering a degree like Muse is that the challenge of computing is very, very high, and young people, unfortunately, are less capable with computers because of controlled ecosystems. So how do we solve that? How do we keep people in flow, which is how do we make them enjoy learning? Well, we just make it a fast feedback loop. Okay? If they keep doing things and getting feedback on it, they feel in control. They get absorbed. So these are 2 concepts. If you want to know more about these concepts, I've given other talks at the ADC and Chime and things like that where I drill into these details, but just kind of bear these in mind with the tools and techniques that I'm going to show you. So I'm going to go through the first module, basically, which is computational thinking, which is basically learning to code through music, but also need to pick up on a few other elements of digital literacy along the way that they might not have encountered. So it's about thinking of music as, well, lots of different things, okay? And probably, everyone's in the room has thought about music in these different ways. Maybe you've not thought about thinking in these different ways, but this is what we encourage on the course. And in that first module, yeah, we're going to learn to code, We're going to use an environment I've developed called Manhattan, which is about procedural music. I'll give a demo of that in a second, where you'll pick up all of the ideas like loops and variables and arrays and things like that in a music environment, in a kind of context of musical creativity, but you'll also learn to think like a computer, okay? How computers work. So the Muse development kit is obviously a nice freebie, but we wanted to give them a computer that they can make their own, they can tear apart, they can upgrade, so that they actually find out how the hardware works, how they install operating systems, they learn command line, and they become a power user, effectively, something that is rarer and rarer these days, but I'm sure you'll agree is critical to a professional practice in audio software development. So yeah, we'll have masterclasses on this alongside coding in Manhattan, and we'll teach them how to think analytically, not just about code, but the whole world. Think about music as patterns and processes rather than just notes on a page. So that's the Muse development kit, and yeah, so you've got a little mini computer there. They'll have to tear it apart, upgrade the RAM, upgrade the hard drive and things like that, install the operating system, make it their own, dig about with it. If they break it, they'll learn. And an I/O device. So this is a programmable I/O device that they can actually, decide what it's going to be. They can program the mappings, the inputs, the outputs, and it's capable of being a MIDI controller or a keyboard controller. But the idea is that they think about interaction, input, output, and they'll be playing around with kind of like, command line again and copying across firmware and mappings. And again, if they break it, they learn. So let me give you a quick crash course in Manhattan. Who's ever used a tracker? Good. Sound trackers, renoise and all that. If you go back far enough, Octamed, maybe, fast tracker. Oh, yes, some hands. Fantastic. Yeah, it's a musical spreadsheet. I know that. And they've been around for ages. And yet no one had the idea to put Excel formulas in the cells. I thought, well, I'll give it a try one Christmas, and that's what Manhattan is. Manhattan is a procedural music environment, which is effectively a sequencer where the notes and events can also be code fragments. So they can decide what the note's going to be as they're being played. They can be based on previous notes and things like that. So yeah, it works a lot like Excel. So it has that very, very low threshold for getting into it, perfect for a first-time programming experience. And it's flipped, right? One of the terrible things about programming is you don't see the data. Okay, you see the process. And that's not great for learners. So in Manhattan, you can see the notes and the data, and you write the code in the background, and you can see exactly what happens to the code. So lots of visualizations about how your code is affecting the song. But it's not just a toy. It's not just musical Excel. It has a low threshold, but it also has a high ceiling. So I'm going to show you a couple of examples of what students actually get up to, and also some of the applications for procedural music in general. Because when you can represent music as not only process, but patterns, well, you can pretty much encode any type of music for any circumstance. The name Manhattan, everyone asks. It's not the Manhattan Project you're thinking of. It's the grid distance, basically. So in computing, up, down, left, right is Manhattan. So it's a weapon of mass creation, not destruction. One of the really key things for those people who might have dabbled in procedural music is it's got a linear idea or non-linear idea of time, in that time actually is represented. So you can address future and past events and things like that. Makes it a very powerful way of mixing traditional composing with procedural and generative elements. This is Manhattan. So as you can see, it looks a lot like a spreadsheet. And why I'm mentioning it now is because we use it on the course, and because inside the program it has a full computer science curriculum that goes through almost every idea in computing and programming through famous pieces of music, which you have to complete with code. So I'm just going to do something quickly now. I'm going to move Pachelbel's canon from 1692 to 1992. Hey. Right, the most exciting cello part ever written for a cello. So let's not actually listen to that. I'm going to go to this cell over here, blank panel, and I'm going to say the pitch for this cell is going to come from channel 0. So we're going to take that cello part, take its pitch, and bump it up 12 semitones, which did not work because it's not channel 1. It's channel. There we go. Okay. Don't know why it's glitching. And then I'm going to basically harmonize that. Okay. So what we're teaching is kind of music as maths. Okay, and we're starting, this is one of the early lessons, this is kind of one of the really easy ideas that you can add things together, numbers together to get beautiful harmonies. So, going to do the same again, but I'm just going to basically take that channel and add 4 semitones, and take the same channel and add 7 semitones, and then once more onto the breach with 11 semitones. Copy those cells and their formulas. So yeah, almost 1992. What's missing from 1990s? It's lesson 3. Yeah, I've effectively taught pointers in lesson 3. That's going to go well. Right, so there's a full computer science curriculum in there. Spend a few weeks at the program, learn the language, and then students are capable of turning almost any piece of music into code. And the results are quite incredible. So download the program. It's on Steam. It's called Manhattan. And that comes with some of the student work in it. I'm going to play you one student piece. Here we go. But yeah, all types of music. It's not just 4 on the floor. Okay, so just briefly, some other applications of procedural music that Manhattan supports as a plugin for Unity and soon Unreal. So here we go. Once you integrate the game with the soundtrack so that the game has note-level access to the soundtrack, well, you can have a lot of fun. This is a defend the castle bow and arrow type game with the orchestra in it. The orchestra playing each of the notes. They do all the usual things. More instruments play when bad guys turn up. And it's part generative and part sequence, so you can put melodies in there. And where's the fun bit? They're mortal. Obviously, you can remove instruments from a soundtrack. But can you make them play worse? Ooh, what's that barrel? It's very close to the orchestra. It's a very brave orchestra. They're related to the guys on the Titanic, I think. I know. Thank you very much. So this is just a sneak peek, very quickly, of a game I'm working on in Unreal, which is basically Britain, the video game. And I'm basically recreating the entire country. So the music here is procedural. It's been generated, so if you watch the video on repeat, it's different every time. It's amazing the data that's out there. But these are just some of the ideas that we try to open students up to. And thinking about music differently, thinking about how music might be different itself in a few years' time. It might be live, it might be dynamic. But yeah, if you want to know more, come to my ADC talk this year in Bristol. And yeah, there should be a playable form of it at the ADC as well. Cool, right. Next module. Where am I? Here he is. Right, they're ready for C++ now. Yay. So yeah, this module, we also actually do as a short course. So this short course is basically 10 weeks, 10 plugins, even if you've never coded before. We've actually got some alumni in the audience. And you can see that actually there's quite a lot in there. And we lie, actually. It's more like 40 plugins. How do we do that? How do we get them into C++? They're making these plugins and learning C++ at the same time. Well, the trick is Clang. Okay, Clang is my language. It's not really a language because it's actually C++. So Clang is a single header include that you can add to any C++ project to give yourself audio syntax and audio semantics, including things like signal flow. And the idea is to reduce the threshold of C++ without moving away from C++, so that you still actually, because it's native C++, you can then compile it anywhere, you have all the performance, and so you don't learn something that's going to be obsolete once you become a professional, because you're learning C++. And you see here the block diagram on the left, nice and simple. It looks like a wah-wah effect or auto-wah effect. Translates to the code on the right pretty linearly. And you can see I've overloaded the stream operators so that you can represent signal flow. But that is completely C++. So it's a great way of making your audio processes more concise, being able to read them as audio processes rather than lines of impenetrable C or C++. It's open source. It's a single header, so if you want to play around with it, it's on GitHub. Yeah, job done, right? C++ easy. Nothing else that's tricky. Oh, except for the environments that we edit C++ in. Okay. Okay, put your hands up if you are a Visual Studio or Xcode user. Okay, keep your hands up if you know what absolutely every feature in those programs does. No, I didn't think so. Oh, hang on, there's one. Oh, that's just a slow hand. Right. So in addition to the kind of reducing the complexity of C++, we put the C++ IDE inside a DAW plugin. You're just your standard synthesizer plugin. Oh, wait, it can be resized. Ooh, it's got some nice pictures. Oh, it's got a button called Edit C++. It's got a whole Clang with a C toolchain in it, so that in a VST or an audio unit, you can actually edit the C++ code of the plugin you're running. So this is absolutely amazing for teaching students. It turns out to be pretty amazing for just prototyping code, because you can make a change to a single line, click build, and say, oh yeah, that's the sound I want. So this is the pillar of the audio processing module and audio programming short course. And it basically allows us to teach people how to develop 40 plugins in 10 weeks or 40 hours. I will leave you to try Clang. It is free. It's on my website, nash.audio/Clang. But if you want a guide to installing it and actually coding audio programming, we have literally just released a plugin boutique short course, 4 plugins in 4 hours. Which gives you a flavor of how we do things at Point Blank. And so it gives you, for example, what we do with the virtual learning environment, a custom virtual learning environment, which is incredibly visually driven, runs web audio, the plugins you'll develop, and you can actually edit C++ and compile code inside the VLE itself to learn kind of concepts in isolation. Have a try with it. The first module is actually for free. Just basically see what we're doing and how we're doing things slightly differently here on Muse. So yeah, and that's pretty much me. And that's also how we get people, from zero code to C++, because by the end of that course, people were already teaching themselves Juice and not scared of it anymore. Please do talk to me throughout the evening if you have any questions about the course. But otherwise, thank you very much.